Do the solve of the second challenge of ROP Emporium. I hope you enjoy it and let's get into it. The last challenge we directly changed the return address with the address of our useful function, and that was the solve. But this time we can't do that because the useful function does not print the content of our flag.txt. So the idea is to overwrite the first parameter to the system call and then call it. To do that, we're going to need a gadget. And here we are like entering the spirit of return-oriented programming, because a gadget is a bunch of instructions that end with a return. Because we need to modify the flow of our program. And return, the instruction, it basically allows us to do that because it pops the first element in the stack and changes the RIP register with the value, with the content of the element in the top of the stack. So what we're going to do is the following. We're going to override the return address with a dummy return, this one, because apparently the system call uses moveups, and moveups require the stack to be 16 byte aligned. If we run directly, our exploit is going, the stack is misaligned, and we're going to cause a sig save, I think. So this like return is there because we use it to align the stack. This is our gadget. It's going to pop RDI and then ret. Basically, the idea is to put the address of the flag, the address of the cat flag string, which does exist, by the way. If we run strings on our and grab the flag, we can see that there's a string in our executable with the command that we need. So we're going to put the address on the stack. When we're going to call the gadget, it's going to modify RDI. RDI will equal the address. And then we're going to call the system func address. It seems like a lot, but it's not, because we're doing what we did last time. We're just adding a few steps. What you need to know is when you call ret, it's equivalent, I think, to pop RIP. RIP contains the instruction that we are about to execute. So every time we're going to, everything we put this in the stack we can go to, and that's how we're going to manipulate the flow of our program. So let's begin the solve. Let's from phone import all. What are going to need is the gadget. The gadget can be, I use roper, and let's give it our and grep pop RDI. Let's grep RDI. Okay, so this is the exact gadget, and just to take the symbols, we need the address of search, I think, the address of the cat bin, and the non-terminator, add flag address. Let's print this, print the gadget, solve. I believe we need to do this just to take the first address. Okay, cool. Now we need the dummy ret. It's going to be gadget +1 because the gadget contains the ret. So we're just moving by one just to take only the ret, and the payload is going to be like last time. The return address offset from the start of our vulnerable buffer is 40, so let's put the dummy ret p64. This is going to align the stack, and then we put the gadget for 8 bytes, p64 gadget, and we add 56 p64 and the address, cat flag address, and then the actual call, which is 64 p64, the system f. We use the symbols, contains all, and system address. Okay, p interactive and p send line payload. Let's open the executable, process split y. Okay, Python solve, and here our flag row placeholder 32 bytes. So the idea is this: we overwrite, just to conclude, we overwrite the return address with the dummy return to align the stack, because system function, because the better engineers than I decided that the move out, no, because move outs is the same function. Anyway, you can search it up. It's the move ups, and I think in this website, I think in the website you can go to view beginner's guide, and there's like an explanation on why the move up issue. Here you can basically see why you need to the bit to be 16. You need the stack to be 16. Hope that helps, and see you in the next one.